Oh, back to me. All right. So let me first kind of reintroduce myself for the sake of the camera. My name's Nicholas, and I worked over at USGS, building an application dedicated to helping scientists discover new data about the rock strata that is blasted on Mars, and that data is sent down to us, of course, and they get to analyze that. And let's just go ahead and get started and get into the meat and bones here. So we're going to have to download a couple things. Obviously, we're going to need to download Python. So let's go ahead and download Miniconda. Or is anyone familiar with Miniconda? Okay, perfect. So go ahead and we're going to go ahead and just Google search Miniconda. I find Miniconda to be very lightly packaged, small version of Python, and with its ability to install virtually any package, I find it to be quite versatile in that regard. There's another version of it called Anaconda that comes with everything. Great for a data scientist who doesn't want to spend a lot of time downloading everything they need. Does everyone already have it installed? Yeah? Okay, perfect. You're going to want to go ahead and open up your command prompt then and download something called PyQT. Whoa. So give it a second. So in here, you're going to install for Mac and Linux, do all that. You're going to need the Qt4 designer. Does everyone have that or no? Okay, so you're going to want to get the Qt designer portion for Windows as well. So go ahead and look that up. Usually it comes with Anaconda. You can run a quick test to make sure it's available, and I'm actually going to see if I can find it. That does not work. Okay, hold on. The worst case scenario, if we cannot get Qt Designer, we can just work with the UI file. It's already technically in here available, so I need you to go ahead and go to this link right here, github.com, and download the skeleton code, and then we'll get started from there. And then show of hands when people are ready to proceed. I don't want to rush too fast.
What's the package name again?
The package is PyQT, and you're going to want to do a conda install, and I'll do that real quick too. So inside your command terminal, you can do conda. Oh, let me blow that up a little bit. Conda install PyQT like that. I obviously already have it, so but it'll still run the package search, and it will then install it. And then I use something called PyCharm, but it's not necessary for this situation. But if you want to install it, so you know what you're doing. I highly recommend that IDE because it makes things a lot easier when it comes to debugging your code, and it shows errors on the fly.
Mine's not available from the current channel. Do you know how to add channels?
Oh, hold on. You got it?
Yeah, it's a 10.
Okay. All right. So, good. So we're just going to go ahead and download the zip file. That's really all we need to do. And then let's go ahead and just actually get started on learning a little bit about the. So why PyQt of all things? PyQt is really powerful. It's cross-platform, so you can use it on Linux, Macintosh, and Windows. So that makes it a very sought-after program because of that cross-platformness. It's easy to use, of course. You can code it obviously in Python. It also comes with C++, and the Python version is actually a wrapper that comes from SIP. SIP is a program within Python that allows you to convert C and C++ packages or code into usable Python code. It's technically a wrapper, so you can't actually see the code. It's kind of hidden underneath there, but at least it allows you to use the functionality that comes along within the C and C++ environment. And of course, Qt Designer for its agile prototyping. Originally, Qt started off as Trolltech. I find that a little amusing to me because in this age of internet and trolls and memeing. So it was started off by two guys, and then it got sold off to Nokia. And you can obviously see that it traded hands a couple of times here. It went from Nokia to Digia, and then it finally became its own company. But the two guys that started it originally started it because they weren't happy with the way building applications was being done. So they went about doing it their own way, and they started, obviously, Qt. So here's some of the applications that it's used in most. Obviously, Dropbox, kind of most familiar to all of us. QGIS, to the guy in blue over here. So if you've messed with any of the QGIS applications, you've been messing with the Qt platform. Spider, if anyone's ever messed with the lightweight Python IDE, I've messed with it a few times. Not a big fan, but it's certainly useful. And then Calibre, which I've used a few times for downloading books into Kindle Fires and stuff. All right, so we're going to start making some headway into actually making our application. So in PyCharm, I'm going to just start up a new application. Even better, I don't even need to do that yet. We're just going to use the Python terminal. Excuse me? Oh. So we're going to go ahead and create a new file. However you guys want to do that in your own system. It's a little slow. Please bear with me. Speed things up a little bit here. We're going to make a new Python file, and we're just going to call it test1. There you go. Now, we're going to go ahead and copy some of this code. It's actually PyQt 5, and so let's go ahead and just start off on the bottom first, because PyQt 5 and PyQt 4, the way they migrated the files is a little different, so it causes a couple different problems. But thankfully, PyCharm has the ability to discover the packages and the directories, so I can show that to you and kind of do kill two birds with one stone here. So let's get out of here and get into here. So we're going to make app equals Q applications sys.argv. And obviously you can already see that it's coloring it in red. A little hard to see, but and then right there you can see that PyCharm has already told me exactly where it is, which makes it super easy. And then it imports it for me. So there you go. So here's actually where it is. So it's pyqt5.qt widgets and then Q application. And I'll blow this up after too. So if I'm going too fast, I'm going to pause. So don't worry too much. All right, so let me explain a little bit about what's going on in here. Looks like a little bit of madness, but it's not too hard. So right here, go away. All right, so right here we're importing a couple things. So that seems pretty obvious. And then we're doing a from PyQt5.qt widgets, and then we're importing a couple different packages. Each of these packages are inside an init file, which you can kind of see a little bit here. Each of the init files holds basically all the information about the basically here, GUI applications. It holds all the information for making the application itself. It's technically an object, and every single time we instantiate an object, we're creating an application. Thankfully, Qt already does a lot of the groundwork for creating the application, so all the intricacies for making the window is already inside that object. So to kind of make class and objects easier to understand, a class is basically the blueprint for everything. It holds all the information and the functionalities for building whatever it may be. In this case, it's an application. And then we obviously have a Q widget, which is also another object that's instantiated from Q application. This is the main application that holds everything. Q widget is the small box that lives inside application. And then right here, we're just showing everything. This app exec executes the code and allows us to close the window afterwards. It basically connects everything into the process of whatever operating system you're working on. So I'm going to go ahead and run it. Oops. There you go. All right, so because I called it test, it's now trying to run a test on it. But here's an empty application, empty window that you can work in. I'm going to go ahead and add a couple of buttons to it. So obviously you can see some of that. Let's go ahead and put a title actually. So we're going to do a window dot set title, window title. And then it's obviously a string, so we can say hello world. This sets the window title. And there you go. An application that says hello world, and it's very simple. It's 5 lines of code right there. Oops. And you can set icons, you can resize the window, or basically set a default size of the window. And you can also populate it with a lot of these particular items, which we'll be working through when we get to the blackjack portion. So you have push buttons, message boxes, labels, etc. Each of these actually all run from the application object/class. So let's go ahead and add a button real quick. So everything, is anyone familiar with the parent-child architecture? And if they are, could they briefly explain it? I saw a head nod over there. You want to explain it to me?
Yeah, it's the relationship between classes, and so a parent class is like a superclass or a base class, and the child class, it inherits everything that the parent class has, and typically has some extra things added to it.
Perfect. So Qt kind of derives from that as well in terms of how it deals with buttons inside its application. You can set buttons, but if you don't ever set the parent, the button ends up being free floating, so to speak. It never actually belongs to the application, and it basically ceases to exist, and it will never show inside the application. So here you can see an instance of that where I go ahead and put Q push button. Obviously it's complaining, so we're just going to import that. So Q, you go ahead and make sure to import your Q push button in there. and then we're going to go ahead and give it a close statement. Now, the important part is that you specify who the parent is right here. So this right here is referencing the parent of QWidget because it's part of the QWidget object. And maybe see a little bit inside here. Well, not really anything interesting. Well, never mind. So we're going to go ahead and run it. And that did not work. Why? Oh, because my window show. Sorry. The window show needs to be at the bottom. And why does it need to be at the bottom? Because everything works from top to bottom, right? So obviously, the window show is happening right after we instantiate our window right here. So none of the content like hello world and close are never being spoken of. So we got to make sure our window show is at the bottom there. We can also resize our button. We can move it around. And here's a message box. And let's go ahead and build a real quick, kind of dirty little application. Oh, never mind. That's really, that's really grayed out there. All right, so the next part is the blackjack game. I kind of sped really fast through most of the introductions. So forgive me for doing that, but I didn't know for sure how long this was going to take to actually build the application. There's a lot of code involved. But I just wanted to give you guys a general gist of how this is going to be working. For the most part, you're importing stuff, you're instantiating a bunch of stuff, and you're adding features to the application, such as buttons, text, and labels. So it's not too difficult. There are a lot of tutorials online available if you want to dig deeper, but for today we're just going to focus on actually getting a working application. So that way you can share it with your friends and family and say, hey, I built this application from the ground up. So let's go ahead. I'm going to go ahead and close this window and start a completely new project. And inside we have, hopefully you guys have downloaded your blackjack game. I'm going to open that real quick. And then I'm going to get all these files to go away. There we go. So I'm going to go ahead and extract it to my home directory, wherever that might be for you guys. And then, am I going too fast? No? Everyone's keeping track? Okay. So here's the game. Slow down? Okay. Yeah. All right. So here's the completed game. It's an executable. There's something called PyInstaller. Hang on. There's something called PyInstaller, which allows you to turn any of the any code that's written in Python into an executable. This doesn't really work on Mac and Linux, but it's good for, say, Windows if you want to turn your application into a single kind of atomized program that you could send to people. So I'm going to...
Stay within 32-bit or 64-bit, though, right? You can't mix the two.
Excuse me?
You have to stay within 64-bit or 32-bit.
It's actually very flexible. So you can use 32 or 64. So... yeah, you can. It's cross-platform in that way. So yeah, you don't have to worry too much about that. So here you can see we already have we have a working game here. Enter a bet. Obviously, I won right there. Enter another bet. We can hit again. Go ahead, decide to stay. So the game is pretty random, and it's not very good at winning. Anyways, let's go ahead and get started. Is everyone seeing what I'm seeing so far? You should have all these files. You got your cards right here, your user interface, and so a lot of the cards are already right here.
I'm sorry, can you remind us what the GitHub URL was?
Oh, yes, sorry.
I didn't get that, I'm sorry. Got that handy up there still.
is used. Actually, I messed up my GitHub repository, so I had to make a second account.
Sorry.
Yeah.
I'm sorry. I know that you're like sensible people.
I guess you can say it's tis a conundrum.
Sorry, everybody. I'm always behind.
All good?
I think I got it.
Perfect. All right, so you're going to want to go ahead and download the zip file. All right, you did all that?
Yeah,
Great.
I'll get that.
Okay. And then just extract that, and then you'll have all these files. And I'm going to go ahead and set up my PyCharm to that location. All right, so the blackjack UI code should already be in there. For the sake of not dealing too much with Qt Designer, because it could take a little bit of time to try and get everyone synchronized. The code's already there, but for those who are curious about what Qt Designer actually looks like, I'll go ahead and open it up. I like it a lot. It's very easy to use. Everything's basically there for you. I'm going to just go ahead and start a main window. And it does essentially a lot of what we've already done, where it's creating a window, it's adding buttons, but the more important part is that it's adding everything correctly. A lot of what Qt does can be kind of confusing with that parent-child model that it follows. If you don't follow everything correctly to a T, you could end up messing up a lot of your buttons and getting lost in the weeds when it comes to getting everything working. So it's very easy to just kind of put in layouts. This is a vertical layout, and I can expand it. So I can make it expanded to fit my box right here. And I can add a push button, which also expands to fit the box. If I delete it, it deletes everything. I can also add another button in here, and I can also take away the layout. And you can then have absolute positioning in your application. So super useful. I definitely do not recommend the absolute positioning when it comes to building your applications, because if someone decides to resize your application, your buttons will literally stay where they are. They do not move like a web page, but if you want them to move like a web page, then you got to make sure to set up your layout correctly, and everything fits nice and orderly. You can also add like file, so you can add actual real application type menus up here. You can also add a little nifty part. I don't use it quite often because it's much easier to just code it directly, but you can also add, let's see where it is. Give me a second. Oh, right, I have to click on this. This right here is signals and slots. So the signal and slot mechanism is one of the more powerful APIs built into Qt. And the reason why it is so powerful, because in a lot of applications, a lot of the signals, as they called it, were sent all the way to the back end to the applications, and then it bubbled back up. Whereas in Qt, a signal and a slot literally connects directly to a functionality within your code. There's no finagling with where that signal, so to speak, is going. And that was one of the key reasons for why the two guys that invented this program or code designed it this way. They hated the way applications were directing a lot of their signals inside the application, because it was getting lost within a lot of the code. So they made it easier. So I won't get too far into the weeds and how it's working, but essentially it creates a there's a couple different options for creating this. Is that it can create a network, so to speak, an internal network within your computer that will send signals to particular parts of the code, and then there's the bit version where it will send bytecode directly to particular functionalities, so kind of like go-tos, so to speak. But anyways, that's kind of a rough estimate of how that's working internally.
Are signals events, like a mouse click?
So if I let me add something real quick. So I can drag and drop something here, and if it's clicked, I can animate it, something like that. So if I click on this, you can see the effect of that. So so that's how that's working. So there are particular items within the application that it can affect directly. As you can see, it can affect user, or it can affect interfaces directly within the application. But more importantly, it can affect the code directly beneath. So you don't have to go 3 layers deep just to get your code to work. Anyways, if you wanted to convert this, there's something called PyUIC. PyUIC 5, yes. So PyUIC will convert this application. It's a UI file. It's written in XML. You could potentially write it by hand. Do not recommend that. Use Qt Designer to do that. You can then put your application directly into here and specify your file. So whatever it might be, .ui, and then you can specify your Python file, like that. Very simple application. It will change all of your code directly into Python. Very easy to work with. Okay, so let's go ahead and get started. We're going to go ahead and open up game functions. You should see an empty skeleton code. So what do we know about blackjack? Obviously, blackjack has a lot of cards, and you have a dealer and you have a player. So you got our dealer, and you got some calculations, and you can hit the cards.
The font size a little bigger.
Oh, yes. Let me just zoom in.
The zoom's a little disorienting.
Is it? Okay.
Yeah, I mean, if you could.
Let me see if I.
When you want to zoom, you can, but I think if you just made the default font size a little bigger.
Okay, let me see if I can do that. So maybe 24. Ooh, that does not work. That does not work. Oh, bad decisions. Font, there it is. That better? A little bit.
I'm getting old, I'm sorry.
No, that's fine.
That's why I'm up here. Oh, I'm gonna have to start doing that, okay. Thank you. Ooh, yeah,
A little too big.
I mean, that's totally visible.
Perfect. All right. All right, so let's see. One moment. Yes, you're welcome. Let me make sure everything's correct on here. Deal cards. There's some functionality that's going to be written later, but I wanted to see if I could set it up where we already write the functionality so we can talk to it directly. Yeah, so let's go ahead and open up Game Start, because some of the functionality for how the deck is working is already written into Game Start. So go ahead and open up Game Start. I'm gonna change the color scheme to white. Hopefully that doesn't kill a bunch of people's eyes. Is this too much? Is that better?
That's good.
Okay, perfect. All right, so we're going to go ahead and be in Game Start this time. So somebody who's familiar with classes and objects, can you tell me what this is?
Class initializer.
So this is a constructor. It initializes the object, so that way it initializes the object with predefined values, and we're going to go ahead and fill that. So technically, how that would look is you would set in an object, and then you could specify some values within it. Obviously, we have 5 values, but this self right here is referencing back into the object, and objects speak within themselves. They talk to other classes. Those are called public. They are called public private functions, but they are private within the class. Classes can talk to those particular objects inside. So we're gonna just go ahead and do this. We need our rank, and we need our suit. All right, so there you go. So this right here is specifying that we have some variables, or in this case, internal values within the class that some of these functions below will be referencing. This repr right here is basically, I tried to look it up, but you said you did Python for a little while, or someone who said they did Python for 7 years. Could you tell me what the repr does? No? Okay. Yeah, so I'm led to believe that it's supposed to mean represent, which is basically how does the code that's coming out of the object going to look. So I feel like that's what they were trying to convey there. And the repr is going to be written like this. We're going to be returning the suit plus the rank. Say that again?
It formats the print statement.
Okay, I figured that's how that was working.
Well, there's string and there's representation. String is just kind of like printing it out, a textual form of it. Representation, I think, is supposed to be, ideally, it's a reversible value. So you print the representation out, and you can actually compile the representation back into the object again.
Right, so there's...
The representation for a string has quotes around it so that you can take that and turn it back into a string again. So
Okay.
a card, you theoretically print out something that you could put back into the class of card object and then have it turn it back into a card again.
Right, okay, well that makes a lot more sense. So right here is string itself, which basically allows you to do something really nifty like this. So if I had a card and then some values inside it, maybe it's a queen, suit 2, some points 2, and then something image.jpg. You could literally print this out like this. And that's what that string does. It will return whatever you decided you wanted to print out in this situation. So if I wanted to return just the suit, it will print out the suit. In this case right here, like he was saying, it's allowing you to do a little bit more than just printing the data that you get. So let's go ahead and get the points. Oh, we're going to return first. And then it's going to be an integer. And why do we want to put, why do we want our points to be, why do we want to do it this way is the question. Why would you want to have int, the function here, and then points? Essentially, it's making sure that whatever comes out is definitely an integer. So if someone decided they wanted to make points a string for whatever reason, that would be denied. You would get an error. And also to make sure that it's not a float. So if someone were to put 13.0 in there for some reason, you would be doubly sure that it's being returned as an integer. So let's get the rank.
It should be more efficient to actually put that on the constructor. That way you only do it once rather than every time you call get point.
That is a good point. We could do that.
Plus, in your constructor, it could do something like say, hey, you gave me some garbage.
That's true. You could put it right here for at the very beginning.
And that way your object is internally consistent.
Mhm.
It always has the correct type in it. You know.
So we're going to go ahead and get the rank. Again, it's again, I put the string in this in here, but like he said, it would be much easier to put it in the constructor early on, so that way when someone tries to run our class right here with some information in it, it would be catched way early on that, hey, you didn't fill this in correctly. So that's a very excellent point. But for now, I'm just going to go ahead and just keep on moving forward, just so we don't get too tangled up. We're going to return the rank. It needs to definitely be a string. And then we need to return the graphic. All right, so next part is the deck. The deck is a function that can be called from, that can just be called directly. It's a bit of a big one, so let's go ahead and just get started. And this right here is a comment. So obviously creates a deck of cards. It's useful. This is useful if you want to say in the future, there's a special program that will go through your code, pull out all the comments that are made like this, and it will construct a documentation directly from your code. So every single time you update your code and add new documentation within your code, this program will update your documentation page on the website. So super useful in that regard. Say that again? Oh yeah? So we're gonna go ahead and put in our rank. So this is a dictionary.
Is it just a displayer, or are they on in different places in the code because it's like they're not tabbed.
The indentation, you mean?
No, the indentation. Sorry, yeah.
Okay. Yeah, especially Python's kind of crazy about that.
Oh wait, so are you asking about the indentation?
Yeah.
The scoping, what scoping do you have to invent that?
Is that a class member or a separate function?
That allows me to do that.
No, it's a module method. It's not attached to the class, it's attached to the module.
Okay.
Oh, sorry.
That's why there's no self on it too. So you ever ask about that? Why
Yes,
is it
yes, yes.
outdented like that from the class?
Yes, sorry. Yeah, this is exactly what you were saying. Sorry, I misunderstood. But essentially the this is an object that holds functionality. This is just a function by itself. Okay, yeah, sorry. We could do something like indenting it directly, but yeah, no, I'm asking.
I try to follow scoping.
Yeah, so indenting this and placing this within the class means that we would have to call card and then deck. So, and everyone understands how dot notations work within calling classes. So if we did indent deck, it would suddenly become card dot deck like this, because it's a function within the actual class. Let's go ahead and add our 2. So if you'll notice, I made my ace an 11 and not a 1. Could anyone maybe make a hypothesis on why that would be a good way of going about that? Excuse me? Oh,
You can just chop off the first one and truncate and just make it 1 that way.
exactly.
1 or 11.
Yeah, exactly. Because in blackjack, ace is considered a 1 or an 11. So if you get a queen and an ace, that's instant blackjack. But say you get a, let's say you get a 9 and an ace, and you decide you want to hit. Well, that brings you up to 20. Obviously, I would never hit that, but say you did. Say I decide I did. And then I get a 3. that ace would suddenly become 1 because I technically fell out of bounds of the number 21. And 21 is the number you want to try and get to in blackjack. So a little bit of typing here. And I'm going to do that. 7, 8, 9, 10. And then Jack, Queen, King. So doing a little efficiency here. So bear with me as I kind of do this weirdness. This is one way of dealing with a lot of numbers. Is you type out all your numbers first, and then you can add the strings, add all the finer details later. And there you go. That is, oh, no, that is wrong. Why is that wrong? Because this is supposed to be straight 10. So in blackjack, all the face cards are considered 10. Does anyone actually know why all the face cards are considered 10? Say it again? Yeah, that was like an actual, yeah, that was just a legitimate question. I never actually understood why blackjack is the way it is, but they're probably, yeah. Dating all the way back to old westerns, I imagine. All right, so next we need the suit. So there are 4 suits, right? You got a spade, a club, a diamond, and hearts. So we got our suit in there. And then we need to be able to create a new deck. So the new deck is going to be used in a second here. Let's go ahead and get our path. So the new deck is going to be referencing all these little cards that are inside the card section. These are a bunch of graphics to add kind of some flavoring to our application. And it's using kind of some nifty string manipulation to call these directly. And when I say string manipulation, I mean it's literally taking these strings from this dictionary and applying it directly to these card values. So as you can see, S2, S, and 2. So it's kind of an efficient way to. Sorry, that's like really small. Can you guys still see that? What I was talking about? Okay. All right, so path equals os.get CWD. So this CWD means current working directory, and it specifies this directory right here. Since this is our working directory. From there, we can basically cheat it and not have to worry about specifying a really long directory like this. Instead, it's pre-specified in path. For key and rank, for S in suit. So I'm just going to write this out, and then I will finish, and then I'll talk about it. Q image lets you parse an image directly from a path and add it to your user interface. And then right here, we're specifying our card. And then finally, we're referencing the actual card class. And then the image. Oops. And then we want to return our new deck. Oops. All right, so let me get rid of that so we can see everything. So let's see, is that okay? Indentation is in Python. It's very picky about indentation. So if you don't do it correctly, it's going to complain. So always make sure that your indentation is done correctly. So what's happening here? It's parsing every single one of these letters in our rank, and then it's parsing every single one of these letters in our suit. And for every single one of these, it's creating a card as a deck. So if you can imagine for a moment this array being full of cards, each card with a key, a rank, and an image attached to it. Now, why would we want to do that? Because we can essentially, inside our program, specify a single card. So we can randomize our deck, pull out a card, and all the details that belong to that card are already in that object. That's super powerful because we don't have to spend a lot of time trying to do all of this. This basically minimizes and optimizes a lot of the work that we would need to do, which you could see up above, right here. All the functionality is done right here. And all we would have to do is specify directly inside our deck the index and then the functionality. So how that would look is something like this. We would specify our new deck, and then maybe I decide to choose the 4th card in that index. And then I could get the points for that particular card inside that deck. All right, moving on. Let's go ahead and create the shoe. The shoe is the size number of the cards. So you can have multiple shoes in blackjack. Sometimes dealers will use up to 5 shoes each. A shoe is a single deck. 5 shoes is 5 decks. If a dealer wants to prevent card counting, they can use multiple shoes. In this case, we're only going to be using 1, so card count away, because there's only 1 player in this situation. But in real life blackjack, if a dealer uses 1 card and they never shuffle the deck, then a person can begin guessing what the next card is, especially if there's 3 or 4 people ahead of them. They can start figuring out exactly what the next card might be and change their bet accordingly. Has anyone seen the movie 21? There you go. Say it again?
Rain Man.
Oh yeah, Rain Man. So we're gonna make another empty dictionary shoe, and then we're going to parse that entire shoe and get the size for it. Oh. Oh, I'm sorry. Yes, and that's correct. Okay. So essentially what that is doing is it's specifying the size of the array and how many cards should be in that array. Because you want it to all be in one single array. In this case, 1 new deck. So early on, you can say, I want 5 shoes, which means that it's going to be 5 times 52. But you don't want to have multiple arrays all holding your decks. Instead, just 1 deck with 5 times 52 cards in it.
So a shoe holds multiple rings.
A shoe is a deck.
Is the 52 card deck. And a deck is a collection of shoes. So you have 1.
Oh, a deck, okay.
Deal card. Okay, so this is the card dealing part where we're going to take the size of the shoe, and then we're going to deal the cards to the particular players at the table. And it looks like, oh, I need to, of course, from random import choice. And there you go. So choice is, if you've ever taken discrete math or any statistics class, you can choose within a particular given set, subset, and pull out a random something. So you would say, I want to choose one marble from a bag of 30 marbles. That would be choice right there. That's what that's doing. But it wouldn't put the card back. That's the special part about choice.
Do you need a parentheses after keys?
Where? Oh, keys. Yes, sorry. Good eye. Dealt card, and then so you obviously want to make sure that the sum of your shoe value is greater than 0. Otherwise, you're basically working with a null deck. There's nothing in the deck, so I can't give you a card. So because as you're dealing cards, you're going to run out of cards. So you want to make sure that you don't run out of cards and you replenish the stock before that happens. So originally when I got this code, this was originally written by somebody else, so that's why some of the stuff that you're seeing is written the way it is. And I'm referencing the way that I had decided to do int and string later on in some functions instead of right away inside the initialization of cards. The guy who had written this originally tried to set up a recursive function right here, and can you imagine what had happened when the value fell below 0? We fell into a recursive stack overflow essentially happened right here because it couldn't replenish the card, but at the same time it kept on trying to dig deeper for a card that didn't exist. So instead we use a while loop because we can specify a little bit more directly when to stop looping. One moment. There is an if statement in here. Something's off. Yeah, unless I'm understanding. Well, let me type it out. Maybe you can do that. Apparently you can do that. Okay, it's been a while since I've seen this code. So apparently you can, a while is technically an if statement. It's a looping if statement. So while something's not true, continue doing it. Else, do something else. So potentially you could do something really dumb like this, while true, and then sticking this all under an if statement like this. You can do that. You could do something like that. You would, in the else statement, of course, you would want to have a break statement, so that way you could fall out of the while loop. But in Python, you're allowed to do that. I've forgotten a little bit.
Do it in MATLAB
All right, we're finally done with the game start portion, and do we want to take a breather, or do you want us to keep on going? Keep going? Keep going. Okay, we'll keep going. All right, so we're finally done with game start. Let's go ahead and work on the game functions. So the functionality is the most important functionality. So obviously we were working on mostly the parts that make up the deck. So next we need to work on dealing with the deck. So if we click on this, you can now see that we're referencing the deck, and this right here is going to be our shoe. So let's see. Game functions, initial cards. So this is the initial cards is the functionality, is the function that tells us who how many cards goes to who. So we're going to have a player hand. We're going to make it 0 for now, and a dealer hand. And we're going to have an array. And then our shoe. So what's happening here? We have a function within an array. This tells us that deal card is going to be returning an array of integers, and you can see that here. Return dealt cards. Right here, it's making a list, and then you can return that list. And obviously, you can stick it inside this list. And then we also want to deal cards to the dealer, and also specify the shoe. All right, so there you go. So now we're going to want to go ahead and return both our dealer's hand and our player's hand. So the dealer and the player need to be returned, and the reason for that is because we're going to be talking to the UI. We need to, when we call this function, the UI needs to be able to know who the dealer and the player are. And in blackjack, if a hand is dealt directly blackjack, we want to let the player win automatically, or whoever it is, dealer or player. I'm going to finish writing this all up right here, but let me show you something kind of nifty with Python. What can you tell me about this little section right here? It's a Boolean, right? So this Boolean returns true and false automatically, right? That means we could technically do something like this, and then erase all of that, right? What did I do here? Oh, thank you. Thank you. Just like that. So you can get rid of a lot of code by recognizing certain functions that return a straight Boolean from the very beginning. So this right here specifies true or false. So why do that extra effort if the thing that you're calling on is going to be returning true and false? So the split is not actually implemented in the UI, so I'm going to go ahead and ignore that for now. In blackjack, you can split your cards depending on if they are similar face cards. So if you have 2 queens, you could potentially split that and double the money you get. In this case, we're not going to do it because it was a little bit harder to implement in the UI. try and get separated units. All right, so we want so when we hit, we want whoever's going to be hit to receive a card, right? So we're just going to go ahead and append the hand. There we go. Hit was pretty easy. And the dealer play. A little comment there, just for the sake of understanding. So when the dealer plays, this is supposed to be kind of a little bit of leverage. The dealer always stays on 16. They cannot hit anymore. And that's just a rule that the house has. In this case, we're going to go ahead and implement it. Let's see, so total. We don't need that. Hit. Dealer hand shoe. Okay, so we're going to be seeing our first recursive function. So what's happening here? First, we're checking to see what the total of the dealer's hand is, and then if the total is less than 17, we're going to go ahead and hit that dealer. We're then going to go ahead and run the function again. Now, how could I have done this with a while loop? I could have easily done this with a while loop by saying, while the total is less than 17, then dealer hit hand, right? We could have done something like this. But in this situation, we decided to go with a little recursion here, just to spice things up. Either or is fine. It's a little dangerous to use recursion because you could hit a Stack Overflow, and that will break your application completely. Whereas in a while loop, I guess either or is both dangerous. With a while loop, it basically shuts down your application and makes it non-responsive. All right, so the hand points needs to have an initial value, right? Sorry, it's trying to predict before I'm even writing. All right, so right here, it's checking each of the cards in the hand, and remember, the hand is a list of a bunch of card objects, right? That's really what is in the hand, and each of these card objects have a cards.getPoint. Let's see what's going on here. Oh, I didn't complete it yet. So if we go inside here, you can see that it's part of the card object, and it's returning the points that are inside each of the cards. All right, let me erase that. It's giving me errors now. And of course, if the total is greater than 21, And this is the part that you were talking about earlier, where we can truncate that 1 off. And this is supposed to be like that. There's probably a much more efficient way of doing that, but that was the way I had written from the very beginning. So so technically all we really need to do is just check to see if everything is greater than 21, check to see if there's an ace. If there is an ace, break off that 10. And I'm sorry, this is this.
What is total if you're over 21? I guess it's,
What if your total is over 21?
oh, you're gonna check that in another function, sorry.
Yes. In fact, that is the next one that's coming up. So, def calculations. Let me make sure I'm on the right there. Oh, definitely do a play. In blackjack, there's something called a push. It's when both the player and the dealer both have the same number of cards or number of points in their hand. Okay, so that was a lot of typing there. So let's kind of start from the beginning. So we're calculating the winning condition here. We're just looking at what the total is for both of the players, and then specifying in some logic who the winner will be. And then the winnings is obviously whatever the person decided to bet. Oops, rate. There you go. All right. There we go. We're finally done with game functions right there. So let's go ahead and do a quick overview of what it's doing. We got our initial cards, what we start off with. We have a function for when it happens when we deal blackjack. We ignored the split. We have a functionality dealing with what happens when the player decides to hit. We have a functionality for dealer playing. We have a functionality for how many points are in a hand, and also dealing with the ace. Finally, we have our calculations, which tell us who gets to win, and then the winnings for whatever the player decides to bet. We just did game start. So next is going to be the blackjack UI. Oh no, sorry. Blackjack UI is just a bunch of code. So let me show you a little bit of it just to humor you. So, like I was saying, PyUIC 5 or PyUIC 4, if you're using Qt4, specifies that you're going to be inputting a UI file and outputting Python code. Here's what this looks like. It's essentially an object, a Q application object that's setting up the user interface. And just like we were doing earlier, where we were setting up buttons, labels, and particular objects, this thing is doing the same thing. But it's very concise in the way it's doing it. So instead of making a lot of implicit ideas about how the application should look, it's writing exactly how the application should look. So it's definitely WYSIWYG, in that whatever you decide to build in Qt Designer is exactly what's going to be spat out by the program. You can see a little bit right here. Set text. You can see some of the cards. When I was designing the user interface, let me show you a little bit about what that kind of looks like. So in the UI, it's a little wild looking because it's discard. All right, so as you can see, there are like a crap ton of cards, right? Why would I do that? I did this because in an application, it's kind of dangerous to dynamically add and delete objects from the application. It's much easier to have some preset items inside the application and make them hidden and unhidden. So in this case, we have a bunch of cards for the dealer and the player, and over time, as the dealer and the player play together, the cards will each get flipped over, so to speak, inside the application. The code merely just hides all of this, and then when the necessary cards are called, they're flipped over or unhidden. I'm going to go ahead and close Qt Designer now. We no longer need it. So we're going to go ahead and open up our objects now, and now we're going to work on the user interface, the fun part, or the functionality, I'm sorry. We're getting to the UI, almost there, we're almost done. All right, so as you can see, like I was just saying, you want to be able to show the card, show the back, hide the card, and your button controls. So let's go ahead and get started on adding that functionality. Now I'm going to hide this again. This one is kind of a long comment. Let me see if I can. So it takes the image of the card from the card class in GameStart and shows it on the UI. There you go. So this is pretty easy. You specify where your image is. You specify what kind of an object it is. And then you specify whether it's hidden. So that's the back end of the card. And then we have to specify the PixMap details. And that's the back end of the card. And now we want to specify the functionality for hiding the cards as they are called.
So I'm a little confused at the 21.
Yes,
Do QPix map twice, so what do we do?
right here.
Yeah.
I think, let me check that. I think it might have been an error. Oh, yeah, you're right. I made a mistake there. It's supposed to be set pix map. Hold on. Image qpix map card UI dot, yeah, dot set pix map. Thank you. All right, now we're getting to the button controls. All right, so the button controls are, like I was saying, using slots and signals, and we're going to do that right here. All right, so there's a lot of false, 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 and true. So this set enable basically turns the button gray and renders it useless. That can be really useful, especially if you want to make it such that the user doesn't use particular functionality of the UI until it's ready to be processed that way. So obviously, at the very beginning of the game, we don't want them hitting or doubling or staying. We want them to set a bet first. Hold on. Let me check something. Something's a little fishy. So taking a breather for a second. So if you want to stand and stretch, I need to check something. That's fishy. All right, let's go back to oops, that doesn't exist. This is in the UI functions. All right, well, that is definitely correctly written. Okay, so the thing that I was kind of bothered by was that bet function was using self, but what's going to be happening here is that the user interface needs to be called upon, and then from there you can specify directly what portions of the UI that you can control. Because what's going to be happening is that when we set the object, the application object, it's going to become part of self. From there, self is technically an object. And then from there, you can specify within self more particular functionalities inside it. So in here, we're specifying self.ui.button bet.set enabled. But this section right here, self.ui, is the part that we want to be controlling. Self UI is the actual application. Self is basically kind of like the foundation which the application stands upon. But you need both of them in order to specify the variable button bet. Does that make sense? So that was the reason why I was a little confused, because we were using self outside of a class. But this is actually possible to do. You can specify the self, and then from there you can specify the object. So let's go ahead and let's go ahead and finish that portion. Okay, this is kind of a long section, so let me explain this portion right here. So obviously, when after we've made a bet, we don't want the person to make another bet. If the person goes over, we want to, or if the person loses too much money, we want them to. The lab warning is basically tells the person when they've ran out of money, what's happening on the field. It's a label that specifies directly what's happening on the field. And let me show you real quick what I'm talking about. So this right here is the label warning. If I say let me double down. All right, and say I put in 502. I enter a bet. I've lost all my money, and I have no more money left. This right here is the label warning. It's specifying that I've lost too much money, but it's going to give me some more money, because infinite banks. Woo! So that's what's clearing right there. This 21 right here is an array with false false. This is specifying who is winning, because we have two hands. So we can specify directly which of those hands are the winning hands. All right, so this D card _0 seems kind of archaic, but that's directly related to the user interface and the naming convention, because each of the cards this stands for dealer card number 0. And there's I think 10. So there's like dealer card 1, 2, all the way up to 9. But in this case, we're specifying dealer card 0 to be flipped over. And in blackjack, the dealer always shows at least 1 card, but the player has to show 2. And here's the upside down card that the dealer has. That is a 1.
So you have 150, you have self.hand 0, 0. What's that?
Okay, so hands this is specifying inside the game function initial cards, because we have the dealer hand and the player hand. So we want to show in the dealer hands 0, 0, because we have 2 players that are playing. So that's where that 21 part was coming from, false, false, because we're specifying whether if the players have reached 21 yet.
So D card 0 is the dealer, D card 1 is the player.
Yeah, so this is from the array self.hands. This is coming from the array initial cards, pulling from the shoe. That makes sense?
So D card 0 and 1 is just how you named it in the GUI.
Yeah, so D card is is referencing the UI object. You can see that right here. It is the blackjack. It is the card itself. You can see card back.ping. That's what that's referencing. And it's specifying what card it is, because this is showing the card, right? But we also want to know what card it is from the dealer's hand. Is it a Queen of Hearts? Is it a Jack of Spades or something like that? That's how that's working. Does that answer your question? Okay, perfect. So here you can see that the player hand is being shown. Every single one of the cards are being shown. The player hand, and then each of the hands afterwards. And the reason for that is because you technically don't know how many cards the player has. It's technically 2, but as each hit occurs, you're going to want to add a card to it, right? For I in if 21. Oops, falling off the edge here. Let me do that. Functions. One sec, I lost my place. All right, so I'm gonna check if the hand is 21, and then we want to show the card. All right. So this is a little archaic looking, and I'll explain this part right now. This is checking to see if there is a 21 directly in the hand of the dealer or the player. So right here, we're checking to see if both players don't have 21. If that's the case, then we want to set the text of the points. If there is a 21, then we want to set the winnings to 1 because automatically it's a push. And then if the player right out of the door gets a 21, then it's 2.5. They get not just twice the winnings, but 2.5, and according to the official rules of blackjack. Most people, when they're programming blackjack, are a little lazy and just go ahead and double the money. But if you really want true blackjack, it's always 2.5. And finally, we're breaking out that if statement, and we're going into our else. All right, and that wraps up our program right here. So there is nothing wrong with this code, which is good. All right, so little review. When when the UI functionality, this is all the functionality for the UI. We want to be able to show the card. We want to show the back of the card. We want to hide the cards, and we want to give control to the functions, we want to give controls to the buttons on the UI. And then finally, the functionality for what happens with the bet when the player makes a bet. All right. We're in the home stretch. We're finally at the main program. And then we'll finally see if this runs without a hitch.
I don't think I write more than like 10 lines of code without writing. If I did it this way, it'd take me 4 days to.
Yeah, no, definitely. I agree. Since this is more of a situation where it's already pre-made, and it's more of a kind of follow along and kind of pick it up as we go. Yeah, absolutely. This project definitely took maybe a week to get it to where it was today. But this is so that way you can kind of hear firsthand how I designed it, why I designed it. When you get home, I fully expect you to definitely take a peek in there, break things, and see why it's working the way it's working. Especially in PyCharm, where it allows you to do something like this. This little red dot is a breakpoint. You can debug your code line by line in PyCharm, which I absolutely love and I use all the time, because without it, I wouldn't be able to tell what is happening to some of my variables. It's kind of maddening when it comes to programming, and you can't tell what is happening to all of your code. So I highly recommend using breakpoints whenever you can. All right, so this main function is a doozy. So crack your knuckles. It's going to get a little long. We are now entering the part that runs the actual application. We will be inheriting directly from our application, which is the blackjack UI. So all of this right here will be inherited. When it comes to developing an application, you do not ever want to edit the code directly inside your user interface. So like, say I wanted to do something dumb like this. Maybe I wanted to hide the card right now. I can do that, but it's very bad practice. And the reason for that is because if you get an error, you're going to have to fish through all this code. And who wants to do that? Not me. I learned a hard lesson when I did something like that. So take it from me, don't add code to the outputted Python code from PyUIC. It even says here, warning, all changes made will be lost. Don't do it. Some restrictions may apply. See store for details. Let's get started. So we're going to be referencing the UI. We're going to be directly entering it into our main into the main object class, blackjack UI.UI blackjack. And that right there is talking to this guy. And then we want to instantiate that object. We instantiated the object. Now we want to call the actual setting up of the UI. So that right here builds our UI right there. Let's go ahead and specify. Oh, not yet. All right. Now we need to. This is all the control settings, where we are setting up what happens when things are being clicked on and touched. Just like that. Now, your mind would tell you that you should put a function in like this, right? But in this situation, we're not doing that. Now, why would we want to do it this way? Because connect is a function that calls a function, meaning that this right here is technically an address. If you get deeper into computer science, everything is an address. Everything is a memory location. So this self.betClicked is technically a memory location. So when I click on this particular button, I'm specifying directly the memory location that's going to be ran. I'm just going to specify all the buttons right now so I can and there's one more. Let's see, I think it's button hit. There we go. All right, so we got our bet, our stay, our double, and our hit. And then we want to, if you're savvy like me, you could do something like this, where you can, like that. So that's a bit of a powerful add-on to PyCharm, where you can do multi-line typing. Super useful if you, instead of copying and pasting.
How did you do that?
What?
How did you do that?
I pressed the Alt key and then I dragged my my cursor around. Yeah, so I pressed the Alt key, left clicked, and then dragged my cursor, and then I can do that.
You should try and wrap up in about 5 minutes.
Excuse me?
You should try and wrap up in about 5 minutes.
Okay. Probably won't be able to, but let me get the bottom part so we can actually run the application. So this is the name and main. So using the same stuff we used earlier to call our application. Oh no. Oh, right. That's all the way up there. Positional argument. See, type error, setup UI missing one, require positional argument, blackjack. Okay. And where is that? Oh, that's in this. Ah, it's missing self. Okay, that should do it. Nope. What did it do now? Hold on. Let me figure out what's going on here.
You need to call super init, it says. So your init routine needs to call the init of the super class.
Right. I know this works because I made it work. All right, what's going on here?
Did you finish yourselves on 15, 16, 17? You didn't finish yourself, did you? On the right.
Ah, yes, you're right. Okay, so that's
You
why.
didn't give it the method name.
Yep. This should work. These work. Okay, so I think I have to call super. Yeah. All right, so what is super? Can anyone answer that question? Yeah, it specifies the parent. So this right here, whenever working with object-oriented programming, you can directly specify another object to inherit particular functionalities and variables, which is super useful if you don't want to have to rewrite the entire an entire class that's basically a copy of another class. You can specify directly that particular class. In this case, we're specifying that we want to copy parts of Q widget. Yay! So we can. So yeah. So the rest of the code, since I got 2 minutes left, you can finish the last portion of the code by yourself. It's not too hard. You can copy and paste from my my repository. I have a complete version of the repository available, so if you want to tinker around with that. If you're also really savvy with GitHub, you can also check out, there's an actual command, you can check out the previous commit, which has all the code written in already. So, thank you guys.
Yeah, thank you very much. Yeah, thank you very much, Nicholas. I'm sorry I read.
Yeah, no, it's a long project, and I'm sorry I had to kind of like steamroll through it. And it's
Kind of give us a good overview of QT and the rules of blackjack and